So I'm Johnny. I'm the CTO and co-founder of Estuary. We're a data infrastructure startup. And just to set the table a little bit, we collectively in this room are e-com. We're an up-and-coming e-commerce company. We work in logistics specifically, so like we're in the warehouse, like warehouse order fulfillment and that kind of thing. Black Friday is coming up. It's our biggest sales day of the year, but management's a little freaked out because last year things did not go so great. There were a lot of snafus in the warehouses. Everyone's really keen just to have a better handle on what's happening within these warehouses so we can like jump on any problems before they actually snowball and become bigger issues. So what we would really like as a company and an organization is to just have a live view that management can use to understand what's happening within all of our warehouses. I've got a Cloud SQL Postgres box running in Google Cloud Platform. We're also running the TPCC benchmark. This is an industry standard kind of load generator, load test for measuring database performance. It sort of simulates like an e-commerce company. It's got warehouses and sales districts and orders and fulfillment and all that kind of thing. So this box is running right now. It's running at, we're throwing like 2,000 to 3,000 queries per second at it. So given the importance of live updates, like management really wants to understand what's happening within our warehouses today as the day is unfolding so we can squash any issues that might arise. Estuary Flow is a real-time data ops platform. So what I mean by that is that it is fundamentally concerned with synchronizing all of your data products. So your databases, your SaaS APIs, your pub subsystems, basically all the places where you generate data and have data, synchronizing all of your data products where they are now to where you want them to be. Again, whether that's an analytics warehouse or a transactional database or a key value store or a pub subsystem, whatever. Flow also lets you sort of transform your data as it's moving through, aggregating it, joining it, taking action generally with your data as it's passing through. But a key thing to understand about Flow is that it is not a database. It is not storing copies of your data. It is really concerned just with coordinating your existing data systems and how data is moving between them. A way I like to think of it is like rather than being a real-time database, Flow is trying to make your existing data systems real-time. There are three fundamental legs for what Flow does. One is capturing data from your data systems, like a database in this case. Data is captured into collections, a Flow collection. And a collection is a collection of your data, which is essentially a real-time data lake. So derivations allow you to transform collections into other kinds of, essentially building collections by transforming other source collections. So building new kinds of data products, aggregations, joins, et cetera. And then materializations are kind of captures in reverse. It's taking collections of data and pushing them into other data systems you have as materialized views. And again, like all the data here is in your systems, your cloud storage, your databases, et cetera. Flow's really concerned with just the movement of data through this topology, through the data systems that you have. And it's doing it in a very incremental way. So it's looking just at what's changing within any given collection and propagating the effects. Like we wrote a new row into a particular database table. That row is now being propagated through all these derivations and transforms and whatnot, and ultimately materialized into all the places where you want that data. Okay, so we have a running capture that my colleague Will set up like a bunch of days ago that's basically just capturing a bunch of tables from this Postgres database into Flow collections. So the next step is we've got to actually materialize this back out again. And that looks an awful lot like creating a capture. We're going to go in, we'll give it a name, and demo. And again, just as with captures, connectors for materializations are essentially Docker container plugins. They can talk to a range of systems. So we built ones already for talking to things like analytics warehouses or cloud storage or tools like Elastic that are more operational in nature, or in this case, the humble Google Sheets. So I'm once again just going to skip to show where I've actually already set this up, but we need a couple of things to get this going. We need like a service account that we can get from Google Cloud Platform, and we need a spreadsheet ID to know what we're actually materializing into. And we've got to pick a couple of a couple of tables that we're actually going to materialize. So I'll materialize like the warehouse collection, and just give it a sheet name that we actually want to, we want the materialization to create within our Google Sheet. So I've, of course, already set this up. Here we can see the running materialization that's just materializing a few different collections into our Google Sheet. So let's actually look at that. Okay, so what we are looking at right now is a live view of essentially a Postgres table that is being live synchronized into this Google Sheet. You can kind of see that as the load generator is making some changes here, in that column I over there, we get some numbers that are changing. But essentially, we're looking at a live view of the database table as that's replicated into this sheet. We have another one here that's a little bit bigger, a couple hundred rows. Same idea, we're seeing live changes of this table. And just to show that, this is kind of fun. I'm going to, so what I'm going to do is we've got this column E here, district name. I'm just going to uppercase every other one through SQL. So I'll just run a SQL command here at the bottom. All that's doing is just uppercasing half the column, half the rows of this table, just so we can see. And it's already been replicated into the sheet. What we just saw was we saw like a warehouses table, 20 rows, great. A districts table, 200 rows, great. Like those are totally fine in Google Sheets. And we saw basically just going from a capture to a materialization, we were able to bring those tables into our Google Sheet. But remember, the original problem statement is we want to understand orders, order fulfillment, order creation, like what's happening within our warehouses with regard to orders for each of them that are, need to be fulfilled. That table is 22 million rows. I mean, it's not a huge amount of data, but that's not going to fit in a Google Sheet. Flow itself, like we could materialize that to another database or a key value store or whatever, and that's totally fine. But Google Sheets itself is probably going to light on fire, or at least my laptop's going to. So we're not going to be able to directly just bring that into a Google Sheet and crunch it there. But what we can do is use derivations to transform the orders table into like a more usable reporting summary that we can actually use. So for example, here we have orders that are being created and orders that are being fulfilled on a per warehouse basis. What we want to understand is just like, what is that looking like on a per warehouse basis as kind of a macro view. What we are looking at here, this is this roll up. So this is essentially rolling up the orders table and looking at all of the pending orders. So essentially, these numbers go up when a new order is created. They go down when an order is fulfilled. We're clearly in like an amazing business, given this is the pending orders for each warehouse. But I think the thing that I really want to convey here is we are seeing these numbers update once a second. That's actually a limitation of Google Sheets. If you try and make updates to Google Sheets any faster than that, Google starts to rate limit you. Flow could happily drive it faster than this. And when we think about this, this is a table with about 22 million rows. It's not an enormous table, but if you ask your database to roll up this view, it's going to take a moment. Like it's perfectly happy to do it, but it's going to take a moment while it's crunching all of that data. And here we're seeing this update incredibly efficiently, because what Flow is doing is it's really just looking at the incremental changes that are going into this view and applying those. Just another example of a report here. Here we're rolling up by date and also by warehouse, just to see like the total fulfillment on a per warehouse basis. And then because this is sheets, what's really neat about like spreadsheets, of course, is they're super flexible just in terms of being able to build out your own dashboards, your own charting, transform data kind of on the fly within the sheet. And it turns out, I wasn't quite sure this would work until we actually built it. It turns out in Google Sheets, if your like data in the sheet is changing in real time, then your charts change too. So we can sit here together and watch funny numbers, essentially like tick these charts over time. Like basically we're watching kind of fulfillments happen within these warehouses. So that's essentially what I have put together just in terms of like demo content to show. Kind of what we've shown with the sheet is we're able to like directly synchronize from our Postgres warehouse into the sheet. We're able to also sort of transform data that's coming from this database on the fly and materialize roll-ups and summaries of what's happening in our Google Sheet with live updates. A couple of kind of like thoughts to, or points to make here as I wrap things up. One is that having set up this capture and capturing data from our database into collections, what's really neat about that is we are able to then use these collections over and over and over again. So for example, if we want to say we've got a bunch of product information in our database and we want to add a new search capability to our website, we can just materialize tables into Elasticsearch. Or if we want to add a new like caching tier to get some of the load off of our database, we want like a cache in front of it that our web app's going to look up into, we can just materialize that into a key value store. So these collections can be repeatedly used for different downstream kind of data processing tasks without ever impacting or touching that database again. Set up the capture once, use it over and over again for different purposes. You can do kind of like, I don't know if this is a good idea or not, but it's kind of fun. You can take a Google Sheet where you're materializing a bunch of live views of what's happening within the business and then capture back from that same Google Sheet. Like say you've got like pricing information in that Google Sheet, capture that back out of the sheet into somewhere else where you're actually using it and serving your business, like serving your e-commerce business. So again, I'm not sure that anybody should actually do that, but it's kind of cool that you can. So call to action, check us out at estuary.dev. You can sign up for our beta. Again, it's a fully managed service. It's also publicly available source code. So we're on github.com/estuary. You can find essentially everything we're doing there. And yeah, I know we haven't really gotten into the architecture or anything too much. We don't, come talk to me, pull me aside. I love talking about that stuff. But otherwise, any questions that people have, I'd love to hear them.
Tell us about the company, your background, the history, all the things.
Yeah. So this has been a bit of a long journey for us, actually. My co-founder and I, we come from ad tech, and we have ad tech backgrounds. That's how we actually met and started working together, was at another company called Invite Media, which was acquired by Google, and we ended up working together very closely there, and then started our own different company in 2014. We were building a business where we really needed to deal with very fast-moving data, and the nature of the business meant that the faster we could process it, the faster we could propagate it through our understanding of what needed to happen, like the more money the business made. So it was just very natural that we needed to work on how to get that data moving and transformed and out again as fast as possible. Estuary as a company is not that old, but kind of the time working on this problem is quite a bit longer.
So your example is focused on Google Sheets as the sort of endpoint. So I'm just wondering, what other things can you push your data to? Like what are the other endpoints?
Yeah, some of the first ones we built were sort of analytics warehouses, like being able to maintain views in Snowflake or BigQuery or Postgres itself. It's super useful to be able to take, if you have like a bunch of SaaS software as a service data sources that you want to bring in and capture and land into your own database so you can work with them there, things of that kind. Quite honestly, we built Sheets in about a week, this Sheets materialization, and we built it for this because I couldn't think of a better way to convey what real-time data means than like just being able to watch it update. It's not quite as cool to watch me materialize into a Postgres database or Snowflake or something. Yeah, the materialization capability is really to all kinds of systems, whether it's key value stores or SaaS services or big analytics warehouses or cloud storage or databases or what have you. Obviously, we haven't been able to build all of this out yet, but the fundamental sort of protocols and capability are in place for all of that.
It sounds like you're not quite in market yet, but when you are, who will you sell to? Given that you're serving folks in the, on the engineering staff, but also those who like spreadsheets.
Yeah, it's a good question. So we actually we're in a closed beta right now, and what that really means is come and sign up, and we just want to know like the use case a little bit to get people up and running. So please do come and check us out. And it's really kind of twofold. One way I think of it is over the last like 5 to 10 years, we've seen a bit of a Cambrian explosion of like really interesting data tools and systems, and a lot of those are now companies. So there are a number of companies that have really interesting data technologies that they offer as managed services that have a fairly similar problem of like how do they get their customers' data in. So one kind of angle we have is essentially enabling these sort of partner companies who want to more easily get their users' data into their product to do so. So that's one. And the other is sort of more like, I don't know what people are going to be able to build with this. I'm not going to know. Like people are far more creative than I am around that. So a bit of the gamble here is just kind of seeing what people come up with and using these tools and putting them together. I mean, quite honestly, the question is a little bit like, what is the use case or who do you sell a database to? It has very broad applicability, and I'm actually very excited to see what people come up with. Cool.
Can you talk a little bit more about how to join multiple data sources together? Like you had that in that last slide with like the MailChimp example or whatever. I'd love to hear like how can we join different data sources and have a combined output that's materialized?
Yeah, totally. I'll answer at a high level, and then I'll also kind of point you at our docs, because just for the audience, I don't want to get too deeply into this. I have a penchant for diving way deeper technically than I really should in any given setting. But at a high level, Flow supports stateful joins and aggregations. Essentially, there are mechanisms within Flow for if you're joining together, for example, data that's coming from your database and data that's coming from MailChimp, and there's some kind of join key, there's some kind of shuffling key that you're joining on, Flow allows you to index that information and keep it around so that the next time you see a record coming from MailChimp or coming from your database, you're able to join against that kind of remembered state. So there's a concept called a register that you'll see within our docs that speaks to this. But essentially, that's the fundamental way you're able to do it. We have some kind of neat ideas for how to take this going forward, but for the product as it exists today, that's the primary mechanism.
I had a question about the middle stage where you're taking all the information from the databases, and you mentioned you could do some joins and things like that, and it seems like you're caching some of the responses, and it's easy to see how, okay, you're just taking a sum of all the different warehouses and incrementally adding to it, but if you're doing joins on that, how big can the data in that middle state get before you run out of memory or just run out of resources or something?
Yeah, totally. So getting into the technical details a little bit, those derivations run as essentially horizontally scalable concerns. So you can take a derivation and it starts up with, you'll see in our docs we call it a shard. So a shard is the actual running thing that is running that particular derivation. And again, just to throw some technical details out, we are using RocksDB to index a lot of that stuff in order to enable those and facilitate those joins. And something kind of cool that we're able to do is essentially take those shards and split them in two in an online fashion. So you can recursively like take that state, split it in two, and allocate it to two different machines in a pretty cheap way. And you can essentially arbitrarily scale out by continuing to split shards as those data, like indexed data volumes get larger.
Hi, thank you so much for your presentation. As you're, I have two questions. As you're moving forward, how are you thinking about like failure states when, like for example, one of like several sources fails and then the stream continues to need to go? And then my second question is, as you're like moving forward as a business, what sort of pricing models are you considering?
Yeah, I'll answer that second one first and then come back to the failure one. So we're charging on usage essentially. So we're charging on the actual like compute resource that's required in order to get these workflows up and running. So we call them shards. When you create a capture, like what you just saw in terms of going from a capture to a materialization, this is all running as two shards, and that's the kind of the unit of pricing. It's similar to like Snowflake compute credits, I suppose. And with regard to failure states, yeah, there are all kinds of reasons why failure can happen. So sometimes there are failures that are just due to the system, that are due to like your database went away. So it's kind of a mix of surfacing that information to the user so they're able to actually take action on it to fix the problem. Another really important failure state is also like schema validation. If data changes, how do you catch that and inform the user before you kind of propagate bad data products downstream. So there's a lot of attention to that within Flow, that we're always validating everything ahead of time.